You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we'll focus on one of the most important distinctions in computing hardware volatile versus non-volatile storage. These two categories define how data is handled, how long it persists, and how system memory operates during and after use. Understanding the differences between these storage types is critical for anyone entering IT because it affects performance, data retention, and system design. This topic also lays the foundation for more advanced concepts like memory management and data recovery. Volatile and non-volatile storage are covered in Domain 2 of the ITF Plus exam, specifically under storage types. You may be asked to identify examples of each, understand their behaviors in specific scenarios, or match a storage type to a computing task. These questions reinforce foundational knowledge of memory architecture and are common in exams that involve troubleshooting, specification evaluation, or selecting hardware for different use cases. Let's begin by defining volatile storage. Volatile storage refers to memory that loses its contents when the system loses power. It is temporary in nature and is primarily used to hold data for active processes. This includes applications that are running, open files being worked on, and any data that needs to be accessed quickly. When the system is turned off or crashes unexpectedly, all information stored in volatile memory is erased, unless it has been saved elsewhere. The most common example of volatile memory is System RAM Random Access Memory. RAM provides extremely fast read and write access, which is why it's used as a working area for software and active data. Volatile memory is crucial for computing speed but is not meant for long-term storage. It exists only to improve the responsiveness of a system during operation. Once the power is off, RAM is empty and ready to be repopulated when the system restarts. Volatile storage has key characteristics that distinguish it from permanent storage. It is designed for speed rather than retention, meaning data is stored temporarily to support active computation. Because of its speed, volatile memory is used for managing operating system processes, executing applications, and storing files currently in use. It supports multitasking, responsiveness, and quick switching between tasks, but should never be relied on for saving important information. Several types of volatile memory exist beyond just RAM. Cache memory, which is built into CPUs, stores frequently accessed instructions and data at even faster speeds than RAM. Video RAM, or VRAM, is another volatile memory type used in graphics cards to hold image data and rendering instructions during games or design tasks. These specialized forms of volatile memory are optimized for specific performance roles in the computing process. Now let's turn to non-volatile storage. This type of memory retains data even when power is lost. It's used for storing the operating system, installed programs, documents, and user files. Non-volatile storage provides the long-term memory that makes computing useful. Whether a computer is on, off, or restarted, non-volatile storage ensures that key data remains accessible and persistent. Non-volatile storage comes in many forms. Hard disk drives, HDDs, are traditional spinning drives that use magnetic platters to store data. Solid-state drives, SSDs, use flash memory to achieve faster speeds and greater durability. USB flash drives, optical media like DVDs, and memory cards also fall into this category. These devices can be internal installed inside a system or external, used for backup or portability. The core difference between these storage types lies in their purpose. Volatile memory provides the workspace needed for real-time performance. It enables applications to run and data to be manipulated instantly. Non-volatile storage, by contrast, serves as the filing cabinet retaining everything from saved documents to application files, even when the device is shut down. Both are needed for a functioning system, one for speed, the other for permanence. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. A simple example illustrates this relationship. When you open a document from your hard drive, it is loaded into RAM so you can edit it quickly. All changes happen in RAM until you hit Save, which writes the updated file back to non-volatile storage. If the computer loses power before saving, those changes are lost because volatile memory doesn't persist. This interaction is at the core of how computing systems operate during daily use. Another common example involves web browsers and media playback. Streaming video is buffered in RAM to allow smooth playback. If the system crashes, the stream resumes from the server, not from local memory. Meanwhile, a downloaded video file saved to your SSD or hard drive will still be there after a reboot. Understanding these behaviors clarifies the importance of saving work and the role of both memory types in providing a seamless computing experience. Speed and cost are two of the most noticeable differences between volatile and non-volatile memory. RAM, being much faster, is also significantly more expensive per gigabyte. It is optimized for speed rather than capacity, which is why systems include only as much RAM as needed for performance. Non-volatile storage, like SSDs or HDDs, is cheaper for large amounts of data and is ideal for storing extensive files such as software libraries, videos, and system backups. The balance between speed and storage volume drives most system design choices. The amount of RAM in a system directly affects its performance. More RAM allows more programs to run simultaneously and helps prevent system slowdowns during multitasking. For example, opening multiple browser tabs, running background applications, and launching productivity tools all rely heavily on available RAM. At the same time, fast, non-volatile storage, such as NVMe SSDs, speeds up boot times and file loading. Together, RAM and permanent storage form a critical performance pair. Many systems use hybrid storage solutions to strike a balance between speed and cost. Some combine a small SSD with a large HDD, allowing the SSD to handle system files and applications, while the HDD stores media and backups. Fusion drives and software caching solutions go further by storing frequently accessed files in RAM or SSD cache to speed up access. These systems automatically manage where data is stored to optimize responsiveness without user intervention. Cloud storage is another form of non-volatile memory that expands capacity beyond the physical limits of a device. Services like Google Drive or OneDrive allow users to store files remotely with redundancy and security managed by a third party. These services synchronize data across devices, offering convenience and data protection. Similarly, removable media like USB drives and SD cards serve as portable non-volatile storage, offering backup options and flexible file sharing. In mobile and embedded systems, storage and memory are often soldered onto the motherboard and not upgradable. These systems use flash-based non-volatile storage for operating systems and apps, with limited RAM for active processing. Because of space and power constraints, they are designed for efficiency rather than performance. Smartphones, tablets, and Internet of Things devices follow this model. The integration of memory and storage in these devices simplifies design but limits flexibility. Another important category of non-volatile memory is firmware storage. BIOS and UEFI firmware are stored in read-only or flash memory chips on the motherboard. These chips retain configuration data, hardware settings, and system initialization instructions. Because they persist without power and rarely change, this storage must be durable and reliable. While firmware can sometimes be updated, the process is tightly controlled and should only be performed with care. Many new learners confuse the terms memory and storage, leading to misunderstandings in support conversations. In everyday speech, memory often refers to RAM, while storage refers to drives like SSDs or HDDs. This distinction is crucial. RAM affects performance during use, while storage determines how much data the system can retain over time. A computer with a lot of storage but little RAM may have trouble multitasking. Clarifying these terms is part of effective user support. It's also important to remember that non-volatile storage does not directly improve speed during live tasks. Upgrading to a faster SSD reduces file access and boot times, but it doesn't improve how fast a program runs once it's loaded into memory. For that, additional RAM is needed. Many users incorrectly assume that more storage equals more speed. Technicians must help users understand how each component affects the system's behavior. The ITF Plus exam may test this topic in several ways. You could be asked to identify whether a storage type is volatile or non-volatile. You might see a question asking which storage component loses its contents when power is lost. Scenario-based questions could present a system crash and ask what type of storage would be affected. Understanding the behavior of these memory types helps you choose the correct answer and explain real-world issues with confidence. Real-world understanding of volatile and non-volatile storage becomes critical during support calls and system troubleshooting. If a user reports that work was lost after a power outage, you can explain how unsaved data in RAM is cleared without warning. If a computer runs slowly during multitasking, you may recommend adding more RAM. If boot times are slow, switching to an SSD may be the best advice. Recognizing how memory and storage interact gives you the insight to solve problems effectively. In business environments, understanding these differences also helps guide hardware purchases. A database server may need more RAM to handle queries quickly, while a file server needs large, reliable, non-volatile storage. Laptop users who rely on cloud sync may not need as much internal storage but could benefit from more RAM. Decisions like these affect cost, usability, and long-term performance, so a technician's ability to match hardware to task is invaluable. The relationship between RAM and storage is also a key factor in operating system design. Virtual memory systems use a portion of non-volatile storage as if it were RAM, helping prevent crashes when physical memory runs out. While this process allows more applications to run, it's much slower than using actual RAM. Technicians need to recognize when a system is swapping data excessively and recommend hardware upgrades or software adjustments to improve performance. To summarize, volatile and non-volatile storage work together to power modern computing systems. Volatile memory, like RAM, provides the speed necessary for live operations, while non-volatile storage ensures that data survives reboots, shutdowns, and crashes. Both play essential roles in system design, performance, and data management. Understanding their characteristics, use cases, and interactions is a fundamental part of technical fluency for both ITF Plus certification and day-to-day technical support. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.